starting again. Welcome for the last part of the conference. We have another set of talks, I think 3 talks. I'm Flav Leitner, and I'll be hosting the last part. And the first talk is from our friends at Intel. It's P4 OVS Split Architecture, Patches and Code. This is a pre-recorded, and we'll check at the end of the talk if the presenters are online to address the questions. Okay, thank you.
Hi everyone, I am Nimrata Limaye, and with me I have Derek Foster and Nupur Uttarwar from Intel. And together we are going to talk about the P4 control plane with the OVS, which is basically the P4 OVS architecture that we presented earlier, and we are moving to a new architecture called Split Architecture. This is the agenda. I'll go over the history. As I mentioned, we started with the P4 OVS integrated or monolithic architecture, and then we moved to the split architecture. I'll go over a little bit over that history. Following that, we'll have the P4 control plane components description by Derek, and then Nupur will go over OVS P4 Runtime Library and implementation of how we are doing it and what the patches will contain, and followed by the conclusion and resources. And then we'll open up for questions and answers. So moving from integrated to split architecture. So in 2020, we created the first monolithic P4 OVS implementation within IPTK-IO, and we open sourced that in October. This implementation basically introduced a new layer parallel to OF Proto, which was called P4 Proto. And what we had integrated, the components of this layer were basically, we integrated Stratum, which is also another open source. And this was basically, Stratum basically supports P4 runtime and open config implementations. And we brought that in within OVS as a part of P4 Proto. And we also included Linux kernel offload functions using Psi, and this was integrated as a part of kernel monitor within P4 Proto in OVS. So the whole idea was based on offloading OVS slow path-like pipeline using P4 into the P4 targets. So in this implementation, we basically programmed a pipeline in P4 just like the OVS slow path, and we offloaded this P4 pipeline into the P4 targets using the P4 runtime and open config facilities, and basically skipped the megaflow and microflow caches that OVS has. So this was a big change in OVS to upstream, and with inputs from multiple places like Red Hat and also some of the customers and internal rethinking, we came up with this new architecture, the P4 control plane or split architecture, we call it now. So basically this architecture separates all the functions into different components. So now we have an infra P40 that contains the P4 runtime and open config that supports both of them using Stratum. And then we also integrate Psi and offload the Linux kernel offload function in the infra P40. And we've implemented OVS Sidecar, which Nupur will go over later, to integrate with the infra P40. And so basically this kind of implementation enabled us to have OVS patches, which will basically contain minimal changes to OVS, and we plan to upstream it, but we plan to send the patches by the end of the year. Over to you, Derek.
Okay. Physically, we have removed the foreign components from OVS. The codebase now consists of a super project, which has OVS and Stratum as submodules and peers at the source code level. Logically, we've created a second daemon called infra P4D. It includes Stratum, which provides P4 runtime and open config support. The kernel monitor, which listens for notifications from the Linux kernel when there are changes in the system's networking configuration. TDI, which is a target neutral interface layer, and then the P4 target, which is the driver for the P4 enabled soft switch or hardware device that underlies the stack. Now, most communication with infra P4D takes place using gRPC. There we have command line clients such as P4RT-CUDL and GNMI-CUDL. We also have an IPU manager for use by Kubernetes. There may be a remote SDN controller. All of these communicating with P4 runtime or via GNMI. Now you may notice from the diagram, OVS is also now communicating with Infra P4D using P4 runtime. And for a discussion of the technology there, I'm going to pass you over to Nupur. Next slide, please.
Thanks, Derek. So OVS P4 Runtime Library, we call it as OVS P4RT. It's a library which will be linked to OVS when OVS is built with P4 support. This library essentially allows OVS vSwitch D and OVS DB server to communicate with P4 runtime to program P4 tables in the P4 control plane based on the information learned from these daemons. And OVS P4RT library will communicate with P4 runtime server, which is integrated as part of Infra P4D over gRPC. Some of the use cases can be programming forwarding tables based on the MAC learning from OVS, or programming tunnel-related tables like encapsulation, decapsulation, based on the tunnel configuration updates from the OVS DB server, which will be used by the pipeline to handle overlay packets, or any port-related updates for that matter. Next slide, please. To minimize the impact on OVS, the approach we have taken is we are building two sidecar libraries called OVS P4RT and OVS DB P4RT, and these will be completely managed by a separate project called Networking Recipe within IPDK-IO. User can wish to link to both these libraries or either of them based on their use case. And once OVS is built with this support, this library will be built separately and then linked to the OVS library statically to create an executable which will have an ability to program P4 tables. And let's consider one example here that programming MAC learned information and the forwarding tables accordingly. So consider a scenario where OVS learned MAC address after processing the ARP packet. So it will send request to OVS P4RT library, and OVS P4RT library will craft a write RPC request saying that I want to insert an entry to a particular table, and the match key can be a MAC address which was learned from OVS, and the action can be just forward to this particular port, and the port ID will be again based on the information learned from OVS. If user chooses to link to both the controllers, the master arbitration between these controllers is handled by OVS P4RT as well. To conclude, the OVS P4 runtime library gives user an ability to control the packet forwarding plane based on the information learned from OVS using P4. Over to you, Derek.
So there you have it. The new architecture is modular. It is easier to update it upstream, and it only makes the necessary changes in OVS. In addition, it introduces the OVS P4 Runtime Library, which allows OVS to integrate with Infra P4D. Next slide, please. So here are 3 resources for you. The first will give you the entire package. You need to do a git clone recursive to fetch it. If you're only interested in looking at the OVS changes, you can fetch just the OVS directory. You'll find the split architecture changes in the split arch branch. And finally, if you'd like more information on the reason for supporting P4 under OVS, there's a YouTube video from OVSCon 2020, and that's the 3rd link. Next slide, please. Thank you very much, and we have some time for questions. Oops, lost the audio.
Hi, Derek, can you hear us?
Yes.
Okay, nice. So he's with us. Does anyone have any questions in the room? All right, we have a 30 seconds delay with the chat, so we are waiting to see if there is anything on the chat.
That's a chat. No questions, Fabio? Not looking at you. Fabio does not have questions. I guess we can move on then.
Okay. So Derek, I think in one of the slides it was mentioned that you plan to submit the patches to the upstream community list this year. Is this still the plan?
Yes, it is.
Okay, and are these patches just focused on the OVS integration part, or you plan to add more components to it?
Within OVS, it will just be the OVS part. We build the sidecar. We build OVS vSwitch D as a static library instead of as an executable. And then in a subsequent stage, we take that library and link it with the sidecar to create the OVS vSwitch D executable. That way we avoid introducing extraneous code into OVS itself.
Okay, so just as a follow-up question for me to clarify, if I want to use this solution, I would have to clone OVS and another project and then build this as a dependency.
Yes, or you could build OVS as in static form directly. We build it from the same build script, but yes, you could incorporate it into another project.
Okay. Okay, thank you. Any other questions? Anyone else? Anything in the chat? No? Okay, let's thank again our speaker.